It's already here. These scientists are about to recreate the power of the sun. They'll use one of the most complex machines ever built. Next to NASA's space station, this is the largest science project in the world. It took thousands of scientists 29 years to build. Its aim? To control one of the most powerful forces in the universe.
Fusion is important because it's something that's going to give us a really, really long-term sustainable energy source.
What Hugh and his colleagues achieve here could fulfill what's now just a dream. An unlimited supply of cheap, clean energy.
We are taking the power source of the sun, which is something very ambitious, and I think it's something very worthwhile attempting to do.
In 1945, the world discovered the power of splitting the atom. All nuclear power today splits atoms, called nuclear fission. From the beginning, it's been controversial. But imagine a nuclear reactor that leaves no deadly radioactive waste. A reactor that can't melt down, and that uses an unlimited, clean source of fuel, fusion. Inside the torus reactor, atoms aren't split apart, they're fused together. A cleaner process that uses no radioactive plutonium or uranium. The fuel for fusion is hydrogen. Hydrogen atoms are heated to 150 million degrees, 10 times hotter than the sun's core. At this extreme temperature, the atoms turn into plasma. The plasma atoms collide and fuse. The reaction releases a neutron of pure energy. It's 1,000,000 times more efficient than today's nuclear power, and 1,000,000,000,000 times more efficient than fossil fuel. Clean energy, but a risky process. More than 160 safety checks take place before the countdown. If one is missed, the forces inside the machine could escape.
Everything we do, we need to be totally sure we've got everything right. We can't afford any mistakes, and it can be a little bit tense at times.
To protect the scientists, the machine is encased inside 6 feet of concrete and steel. Even so, the scientists work from the safety of a separate building.
Trigger the pulse, please.
A camera records the reaction. The glowing light is plasma heated to 150 million degrees. The reaction produces energy just like our sun. In mere seconds, fusion here on Earth.
We did good.
That was excellent. That worked exactly as we wanted it.
It's perfect.
I'm happy. I think the scientific coordinators are very happy. You can see lots of smiles on that, which is good.
Nowhere in the world have scientists come closer to creating the ultimate energy source. And the fuel for fusion is virtually unlimited.
One bathful of water would provide enough energy through fusion to supply one person with all their energy needs. So their transport, their heating, their food, their industrial needs, for 30 years.
Because fusion uses water, there are no security risks, no meltdowns, no downside at all to living next door to a fusion reactor. But don't look for one soon. Scientists estimate it will take 50 years before we have a working fusion power plant.
This is a very long-term strategy. This isn't something that's suddenly going to produce a result tomorrow and solve all our problems.